Alright, another solid revolution, same shape. We want to find the volume of the solid formed when the shaded region is rotated around the y-axis using disks and using shells. And I'll go a little bit faster than the first video because I just don't want to spend too much time on this. But alright, the y-axis is right here. Well, sort of. I'll retry that. That was pretty darn bad. Alright, the y-axis is right here. And if we're rotating around the y-axis, what happens is this comes around and comes back around that way. So actually it's going to be a lot shaped like the top of this parabola. I don't know, is that called a paraboloid? Sounds cool, so I'll say paraboloid again. I'm not positive that is exactly the right term, but so what happens is we have a shape that looks like this, and I'll try to draw it as well as I can. It's going to be a little bit harder because I need to get this section right. Alright, so there's the back. I have my y-axis cutting right through it. And now let me bring in everything else. We get the front, that's in front of the y-axis obviously, and the cap of it is a parabola. Okay. Alright, there's the shape. And let me shade that shape in a little bit nicer because, I don't know, I feel like it. So, let's see, let's do this. Alright, so here we go. So you can see that we have this sort of hill shape right here. That, well, that's not as nice as the last ones, but you get the idea. We have this hill-shaped mound. It looks like a pile of dirt or something, pile of sand, not pointy at the top. And so from here now, let me see if I can do a little bit nicer with that. Okay, so no, I can't. All right, so here we go. We want to find now using disks and shells. Let me first do this with disks. And there's a problem here. And the problem is, if I cut this into disks, all right, I'm going to cut it this way, across the y-axis horizontally. And what's going to happen is this. I'm going to cut it across, and I will get a shape like this. Let me see, that's not so good. And the shape will look like this. Okay, let me make it a little bit darker so I can really see it. Okay. So it'll look like this if I cut it off, and if I look at it dead on, it will of course be a circle because it is a solid of revolution. And here's the important piece. In order to find the volume, I need to find the radius of this circle, okay? This radius here will measure this radius here. It's a little bit hard to see. So this I'll call R. This I'll call R. This I'll call R. But here's the big problem here. This radius can be measured by the distance from 0 to the x value of this function. I have the y value, so I actually need to go about and solve this. Now we saw that in the first problem, so I'll do that quickly. So we have solve this for x, so I know this length. So y equals -3 over 16 x squared plus 3, subtract 3 from both sides, y minus 3 equals negative 3/16 x squared. Multiply by negative 16/3, I get negative 16 over 3, y plus 16 equals x squared, and that means x will equal the square root of, and I'll write this around a little bit, 16 minus 16/3 y. So if I am finding disks revolved around the y-axis, I need a function for x in terms of y. So this radius, so r will equal x, which equals, because I want to know what happens at any value y as I go along this axis. You can see the radii are changing, which is going to equal the square root of 16 minus 16 over 3y. And I know that the area of each of these circles is area equals pi r squared, but radius is going to be this value right here. So the area in terms of y will equal pi multiplied by what I know the radius has to be, square root of 16 minus 16/3 y squared. And if you recall, the disk method, or the method for finding the volume of any solid, I can use, so volume will equal the integral from the starting to stopping, a to b. Now I'm just going to jump straight to 0 all the way up to 3. I'm going up the y's from 0 to 3 of the area in terms of y in this case, so pi times the square root of 16 minus 16/3 y squared dy. And you might be more used to seeing this. I can bring the pi out, so that'll equal pi multiplied by the integral from 0 to 3, and the square root squared, well, those cancel, so I'm left with 16 minus 16/3 y dy. And again, I can do this one by hand. This is actually a really easy integral, but I'm lazy. Let me do the calculator. So, turn around. Okay, pi, math, 9. For f and int, I'm going to do 16 minus 16 divided by 3 times, let me do times y with respect to y as I go from 0 up to 3. And this gives me approximately 75.398. So that's approximately equal to 75.398.